Hi to all. In this video, we're going to see about Introduction 3 Power System Analysis 2 17E 71 Module 1. Okay, code tree, the set of branches of the original graph G not included in the tree is called the code tree. Okay, code tree is the tree which will not be connected or may be connected. The code tree could be connected or not connected, closed or open. The branches of the code tree are called links. By convention, the tree elements are shown as the solid lines, while the code tree elements are shown in the dotted lines in figure. Okay, for the trees. Okay. The number of links L is equal to E minus B is equal to E minus N plus 1. Okay, for a graph, figure 1c, tree is T123, T146, T245, whereas co-trees are 456, 235, 136. Basic loops. When the link is added to a tree, it forms a closed path, okay, or a loop. Okay, addition of each subsequent link forms a corresponding loop. A loop containing only one link and remaining branches is called basic loop, okay, or fundamental loop. These loops are defined for a particular tree. Since each link is associated with a basic loop, the number of basic loops is equal to the number of links. Basic cut sets which contains only one branch and remaining links are called basic cut sets, okay, or fundamental cut sets, just like loops, basic loops. Okay, the basic cut sets are defined for particular tree. Since each branch is associated with a basic cut set, the number of basic cut sets is equal to the number of branches. Okay, now we go for rule of inspection. We go for consider the three nodes admittance network as shown in the figure. Okay, using the basic branch relations, I is equal to Vy for all elements, elemental currents, and applying Kirchhoff's current law principle at the nodal point, we get the relation as under. At node 1, this is the node 1, this is the node 3, and this will be the node 2. Okay, at node 1 we are getting y1 v1 y1 and v1 plus y3, v1 minus v3, okay, and plus y6. So in this node y1 is coming, y3 is coming, and y6 is there. So at node 2, this will be node 2, y6 will be there, and y2 will be there, and y5. So y2 v2 plus y5, y5 v2 minus v3, okay, plus y6 v2 minus v1. At node 3, this is the node 3, here y3 y4 and y5 are connected. So y3 v3 minus v1, so y3 plus y4 into v3 plus y5 into v3 minus v2. Okay, so these are the performance equations of a given network in admittance form, and they can be represented in matrix form as y1 plus i1 i2 0, because we have only two current sources, so i1 and i2 and 0, that is equal to y1 plus y2 y3 plus y6 y1 plus y3. When we simplifying this one, we'll get the values of like this: y1 plus y3 plus y6 minus y6 minus y3 minus y6 y2 plus y5 plus y6 y3 minus y5 y3 plus y4 plus y5 multiply with v1 v2 and v3. Okay, just like a matrix. Okay, in other words, the relations of equation 9, this okay, equation 9, we get, okay, I bus is equal to y bus e bus, Okay, where Y bus is the bus admittance matrix. I bus and E bus are the bus current and bus voltage vectors respectively. By observing the elements of the bus admittance matrix, Y bus of equation 13, okay, it's observed that the matrix elements can be as well as obtained by a simple inspection of the given system diagram. Diagonal elements. Diagonal elements y1 of the bus admittance matrix Y bus is equal to the sub total of the admittance values of the all the elements incidents at Y bus bar node J I. Okay. Um, Off diagonal elements and off diagonal elements Yij of the bus admittance matrix Y bus is equal to the negative of the admittance value of the connecting elements present between the buses I and J. If any, okay, this is the principle of the rule of inspection. Thus, the algorithmic equations for the rule of inspection Yii is equal to S into Y ij. J is equal to 1 2 3 so on, and Yij is equal to minus Yi, that is J is equal to 1 2 3 so on. For I is equal to 1 2 and so on, no number of buses given system Yij is the admittance of elements connected between buses I and J, and Yii is the admittance of elements connected between bus and ground reference bus impedance matrix. Okay, in case where the bus impedance matrix is also required, it cannot be formed by direct inspection of the given system diagram. However, the bus admittance matrix determined by the rule of the inspection following the steps explained above can be inverted because admittance and impedance are inverting property. Z is equal to 1 by A, or okay, so we can take admittance bus 1 by Y is equal to Z. So we can find the value. It is noted that rule of inspection can be applied only to those power systems that do not have any mutually coupled elements. If the mutually coupled elements are there, then the values will be changed. Okay. Example of rule of inspection. Uh, Obtain the bus admittance matrix for the admittance network shown by the rule of inspection. For this Y bus is equal to, they are given the value like this. Okay, so example of 7, obtain Y bus impedance. So we can find the values is equal to Z bus is equal to Y bus inverse, because Y bus is equal to admittance and Z bus impedance both will be um, inversely is there, no, so values will get the values like this. Okay, so from this we'll get Y bus is Y bus is equal to generator 1, generator 2, this will be the transmission, and this is a load. Okay, if we simplify this one, we will get this one, and we'll get Y bus is equal to J minus 8.66 7.86 7.86 minus 8.66. We'll get the values, and Y bus new is equal to Ya minus Yb uh, dash inverse or into Yc. So we know the Ya, Yb and Yc. From that values we can find that values. We'll get the value of Y bus is equal to J into um, minus 8.66 7.86 per unit values. These values are called per unit values. Okay, thank you.